The universe whispers secrets in waves, but some are allegedly silenced. Could high-frequency gravitational waves be the key to unlocking unimaginable technologies? And has the truth been hidden from us? These waves, if real, could revolutionize everything from communication to space travel. Today, we'll explore the claims of discovery, the whispers of a cover-up, and the patents that suggest something extraordinary is happening. Join me as we delve into the enigma of high-frequency gravitational waves. Gravitational waves are ripples in spacetime caused by accelerating massive objects, like colliding black holes. We've detected low-frequency gravitational waves, but the real game-changer could be their high-frequency counterparts. High-frequency gravitational waves, if we can harness them, could unlock advanced communication systems that penetrate any barrier, enable interstellar travel, and even provide limitless energy. The potential is staggering. Decades ago, Townsend Brown claimed to have generated high-frequency gravitational waves in his lab. He demonstrated devices that seemed to defy gravity, exhibiting unusual propulsion effects. Then, silence. His research vanished, shrouded in mystery. Was it suppressed? Did it simply lack scientific rigor? Brown's work, while controversial, is a crucial part of the story. Brown's devices? Brown's experiments primarily involved capacitors made of a dielectric material, sandwiched between two conductive plates. He would apply a high voltage, typically AC, across these capacitors. Crucially, he oriented these devices with the positive electrode facing upwards. The Biefeld-Brown effect. Brown claimed to observe what's now sometimes called the Biefeld-Brown effect. The capacitors appeared to move in the direction of the positive electrode, seemingly defying gravity. He even built a saucer device, a circular capacitor arrangement, that he claimed could achieve significant lift. Claims and controversy. Brown attributed this effect to an interaction between the electric field and gravity, suggesting he was generating or manipulating some form of gravitational radiation, possibly high-frequency gravitational waves. However, the scientific community largely attributed the observed movement to more conventional explanations, such as ionic wind or electrohydrodynamics, the movement of air due to electrical forces. Brown's lack of rigorous scientific methodology and the absence of peer-reviewed publications further fueled the skepticism. Connection to high-frequency gravitational waves. While the exact mechanism behind Brown's observations remains debated, some proponents suggest that the high-frequency AC fields he used could have generated high-frequency gravitational waves, which in turn interacted with the device and its surroundings. Years later, Dr. Ning Li, a physicist at the University of Alabama in Huntsville, echoed Brown's claims. Li and her team conducted experiments involving rotating superconducting rings and pulsed magnetic fields. Their research, published in peer-reviewed journals, suggested an interaction between these rotating electromagnetic fields and gravity. Li's work focused on measuring minute changes in the gravitational field around the rotating superconducting rings. She reported detecting a decrease in gravity, which she interpreted as evidence of the generation or manipulation of gravitomagnetic fields, a component of gravitational waves. Her experiments were designed to test theoretical predictions about the coupling between electromagnetism and gravity. Like Brown, Li's research involved unusual propulsion effects. While the mechanisms were different, both researchers reported observations that defied conventional understanding of gravity. This raises the question, were they both observing the same underlying phenomenon, perhaps related to high-frequency gravitational waves? Similar to Brown's research, Li's work also seemed to fade from prominence. While she published some initial findings, further research and development in this area appeared to stall. Was funding withdrawn? Were there unforeseen challenges? The reasons for the apparent slowdown remain unclear. The parallels between Brown and Li's work are striking. Both claimed to have observed unusual gravitational effects. Both worked with electromagnetic fields, and both saw their research seemingly disappear. Is this just coincidence, or does it point to something more? Now let's fast forward to the present day. Salvatore Pais, an aerospace engineer, has filed several patents related to high-frequency gravitational wave technology. These patents, assigned to the US Navy, describe some rather extraordinary devices. Pais's patents detail a device designed to generate extremely powerful electromagnetic fields. These fields, he argues, can interact with space-time itself, potentially creating or manipulating gravitational fields, including high-frequency gravitational waves. The patent suggests that by manipulating electromagnetic fields in a specific way, it might be possible to generate or amplify high-frequency gravitational waves. One patent goes even further, describing a space-time manipulation device that could potentially warp space-time, enabling faster-than-light travel. This device relies on the principle of manipulating gravitational fields, potentially through the use of high-frequency gravitational waves. While the patents don't explicitly mention high-frequency gravitational waves by name, the underlying principles and the described effects strongly suggest a connection to this elusive phenomenon. The patents talk about manipulating gravity, altering space-time, and generating powerful electromagnetic fields, all concepts closely related to high-frequency gravitational waves. The fact that the Navy has shown interest in these patents raises some serious questions. Does this validate Pais's claims? Does it suggest ongoing government research in this highly classified area? It certainly raises some eyebrows. Robert M. L. Baker Jr. has extensively researched the potential applications of high-frequency gravitational waves. His work, detailed in publications like Applications of High-Frequency Gravitational Waves, paints a picture of a future transformed by this technology. Advanced propulsion. Baker discusses the possibility of using high-frequency gravitational waves to create gravity-like forces, enabling spacecraft to achieve incredible speeds without the need for traditional propellants. Imagine interstellar travel becoming a reality. Communication. High-frequency gravitational waves could revolutionize communication. Because they interact weakly with matter, they could potentially transmit signals through anything, including planets and stars. This could open up new possibilities for deep space communication, and even communication with extraterrestrial civilizations. Energy. Baker's research also touches on the potential for high-frequency gravitational waves to interact with zero-point energy a theoretical source of limitless energy. If this is possible, it could solve the world's energy crisis. Sensing and navigation. High-frequency gravitational waves could be used for advanced sensing and navigation systems. They could provide highly accurate measurements of distance, velocity, and even the internal structure of objects, weaponry. While Baker's focus is on peaceful applications, the potential for high-frequency gravitational waves to be used as weapons cannot be ignored. The ability to manipulate gravity could have significant military implications. Baker's vision, if high-frequency gravitational waves are real, is a future we can barely comprehend. It's a future where the limitations of space and time are potentially overcome. So, what do the experts say? The scientific community is divided. Some believe that high-frequency gravitational waves are purely theoretical, while others suggest that they could be real, but incredibly difficult to detect. There's limited direct evidence of high-frequency gravitational waves, but the work of Brown, Li, Pais, and Baker, while controversial, cannot be entirely dismissed. More research is crucial. We need to investigate these claims, to replicate experiments, and to seek definitive proof. The challenges are immense. Detecting high-frequency gravitational waves requires incredibly sensitive instruments, and distinguishing them from other forms of background noise is a monumental task. Furthermore, the theoretical models for how high-frequency gravitational waves are generated and interact with matter are still being developed. However, the potential rewards of confirming their existence and harnessing their power are so significant that the pursuit is undoubtedly worthwhile. We need more funding, more collaboration, and more open discussion about these potentially revolutionary ideas. The story of high-frequency gravitational waves is a complex puzzle. We have claims of discovery, whispers of a cover-up, and patents that hint at a technological revolution. Are we on the verge of a breakthrough that could reshape our world? Or is this just an elaborate conspiracy theory? The truth is, we don't yet know. But one thing is certain. The potential of high-frequency gravitational waves is too significant to ignore. We need transparency, open scientific inquiry, and a commitment to exploring the unknown. What do you think? Let me know in the comments below, and don't forget to like and subscribe for more explorations into the mysteries of the universe. This video is based on publicly available information. The claims presented should be critically evaluated and considered within the context of ongoing scientific research and debate. The existence and practical application of high-frequency gravitational waves are not yet scientifically established.